Hi everyone, it is February week 2. We have some new features to show off. Let's get started. First up, we have Larry.
All right, so I'm going to show off some new operators we've added to our update by table feature. And let me just recap real quick what update by is. It's a little bit of a combination of our update operator, which will add the new columns to a table without replacing the existing ones. But it's also a little bit like aggregation and ag by, and that it can compute aggregate data over a subgroup of data. So I'll give some demonstrations. But there's kind of two flavors of update by operators. There's the cumulative ones, which effectively will start from the beginning of the table and then compute all the way up to the current row and then display the value. And then we have kind of a new concept introduced in the January release that is a windowed set of data, which means from the current row, you can look forward and backward either in time or in rows and compute a group based on that. So I'm going to bring in some real simple data. This is a fairly simple column. There is 2 million rows, just so you know I'm not cheating. All I want to show is the region, some units sold, and then some data information. So the operations that we have right now, we have rolling sum, which is a windowed sum of values, EMA, exponential moving average, a forward fill, a cumulative product, and a cumulative sum. So the first thing I'm going to show you is effectively our compare the cumulative sum operator to the rolling sum operator over this data. And so I can show that over this data, and I'm not doing any kind of subgrouping. So this is the cumulative sum over all the values. And this is the rolling sum of 100 rows. So you can see these mirror all the way up, exactly up until we get to effectively our 100th row. And now this is the rolling sum. And this will just mirror for every row the rolling sum of the 100 rows in front of it. There we go, just to the end of the table with 2 millionth record. There's the cumulative sum over all the rows, and then the rolling sum of the last 100 rows. I can also show you the EMA is kind of a surrogate for average when a pure rolling average is not available. So this can demonstrate an EMA versus a rolling average, again, of 100. And you can see, just pick any point, the EMA is not very volatile, but the rolling average is actually more volatile and jagged, as you would expect to see as values pop on and pop off out of the window. Okay, and then we're not limited to just doing averages over the entire table. As with other operators, we allow you to group data. So what this is the cumulative sum versus rolling sum, but now it's going to bucket it by region. So again, it's not going to rearrange the data in any way. It's just that the values that's going to be computed for cumulative sum and rolling sum will be unique to the buckets in which the row is found. So let's run this, and you pick any one of these. But now the cumulative sum and the rolling sum are computed individually for the bucket for this region. So let's just pick Europe. So these two, cumulative sum and rolling sum, are correct. They would match each other. These Europes match each other, but they don't. Europe does not contain any data from the Asia group and so on. And again, as we go deeper into the table, you'll see there's a unique rolling sum. There's a unique rolling sum for this region and a unique rolling sum for all these regions. Okay, and then I can do the same thing for EMA. I'm not going to go into it too much. I'll just run it, and you can see that these are different values for the bucketed EMA and the rolling average. And then this is something that's pretty cool. We're using this under the hood in some places, but we can actually show you a group of the data that is contained in the window. So this rolling group operator will actually show me all of the units sold that are within 100 rows of the current row for each region. So if I just pop this, you can see that, okay, here's the units sold for Australia, Oceania. Here's Europe. This row, Europe contains itself, and there is no previous record, but this one contains itself and the previous record, and so on. So you can see how these quickly accumulate. And as you get to the end of the table, all of these have a unique set of data items, but they are specific to the region in which you're found and they contain the last 100 values. But of course, we're Deephaven, and static data isn't that interesting. So here's a quick recap of ticking data. This is just a 1 row per second type data, and I'm going to just run through these pretty quickly. I did do some differences here where now I'm not just doing a backward window, but a forward-looking window as well. So because we're now appending data, you'll see that our rolling sum is actually, for any particular row, is accumulating a new value as data enters the table, because it's now within 10 rows. And then once the data is, the newest record is more than 10 rows away, now this has become static. It's not actually become static, of course. If any rows were to be inserted in the middle, this would operate or recompute to be correct. So similar type stuff, but we're ticking data. Here is an EMA over a rolling average. And then the bucketed versions of these to show that we can compute these dynamically, individual for each, in this case, in each region. And this one I think is actually pretty cool. I did this rolling group as a forward-looking group only. So what this is showing for each individual row, it'll show the data items of the next 10 rows. But you'll notice it's not inclusive of itself, which can be demonstrated down here, where in this case, Europe does not have a following record and won't for another couple seconds. But when now there is a valid record in effectively the future for it, but really just in the window that is satisfied by looking ahead 10 rows. And so that's some of the operators we've got currently. We have more planned. We're going to be doing rolling minimum, rolling maximum, rolling products, rolling weighted averages, possibly a rolling count, and then variants of the exponential moving sum, and a exponential maximum, and then probably a delta operator for our cumulative. And that's what we have going on.
Very cool. Rory, you want to take over?
Yeah, sure. Let me share my screen, my window here. Hopefully this will work. So the context here is that I'm working on the Python client and making kind of incremental improvements to it. What I had sort of promised was that in our last iteration, I had sort of a working API that was maybe a little bit too low level or not especially Pythonic, and I claimed that, well, that's really just sort of a core, and you can wrap sort of a nicer API of your preference, whatever you like, kind of on top of that. And this is going to be sort of a demo that has been successful. So I'm going to take my favorite example my go-to example, which is one where I subscribe to a table, I look at a column, and I kind of dynamically compute its running sum by looking at the adds, removes, and modifies. So this should be a familiar program from before. It's just Python. This is the usual ceremony that I do to kind of connect to my table. And I give it a Python class, which is this thing called callback handler. This might also look the same as before. For now, this isn't necessarily the final API, but for now, I take the low-level update thing that I get from my library, and I'm like, oh, I'm just going to pass it into this little adapter, which is sort of a low-level to high-level adapter. And from that point, I am using these API calls, which are, let's say copied or stolen or adapted from our table listener API. It's pretty much virtually identical, if not exactly identical. So I've got a removed method, which takes a variety of optional parameters and gives me a generator, which gives me the removed rows, the added rows, the modified rows, as they look previously and the modified rows as they look currently. And because this is so regular, I pass each of those chunks, kind of like before, my little trick where I pass each of those generators in turn to my little processing routine, which is here, this process deltas thing. And that's even simpler looking now. Sorry, I keep even simpler. So I basically iterate over the chunks in the generator, get the column out of it, which I have sort of predefined its name here, and sum them up. It's kind of like easy peasy. Now I'm doing this all in one file, so we could even look at the adapter itself, which itself is actually not that big a deal. It is for there's also a copy of this. I'll have to tell you this is pretty much. This is 4 clauses that are virtually identical. They're basically they have to do with whether you're looking at the removed or the added or the modified. But basically, a bunch of optional arguments. I pick out the piece of the sort of ticking update that I need to process, and I pass the collected arguments and whichever part of ticking update I care about to another helper method called make generator, which is this thing. And this routine looks just like this routine, looks just like this routine, modulo just the little details that change between those. And finally, the most internal helper method, even the thing that makes a generator, which is this nice thing. So it's not quite fitting on my screen, but you can see that even that is quite short. Do a little drama with the normalize my arguments, set up my buffers, and then this is kind of the adapter layer where I'm doing the kind of low level take and drop stuff from the API that I sort of prefer. Someone's dog is coming through on the audio. And just turn it into generator and turn it into a dictionary. I allocate my NumPy arrays and I yield the result. This is sort of the typical kind of generator style for Python. And that's I just literally showed you the whole program from top to bottom. And I could run it if we care. It kind of works as before, but I'm kind of ready to go on that, so I could do it. This is my usual thing with like a million rows that are all changing every second due to the Java random number generator. And then over here, should be able to run it. I always forget to do that. I should be able to run it. Oh my gosh, and I always forget to do that. This is like live. Be able to run it. We'll edit those other parts out. And then you'll see these kind of sums coming through here. And hopefully that's the same sum that we're computing over on the server side, which I could demo here. But so hopefully that's the same. Looks like it's the same. So that's it. That's my demo.
Great. That's it for this week. Thanks, everyone. Bye.
Is